Hello everyone. We will be starting Masterclass 5 in next 2 minutes. Request each one of you to please ask your team members to join the meeting. And we will be, yeah, request each one of you to please ask your team members to join in the meeting. We will be starting soon. Thank you so much. All right. A very good evening to each one of you. Thank you so much, everyone, for joining in for Masterclass 5 of Data Analytics Internship Program. Hope you all are done with, other requirements of this internship, and hope you all are doing well with respect to your, learning plan and then concept note, and also working on your projects. And we have in our midst, uh, we have Jayati Kaushik ma'am, and she has already taken masterclass 2 masterclasses with you all, and today is the second last masterclass of this internship program. And I hope all of you have greatly benefited from this internship program, and I'm sure if you will focus well, Jayati ma'am has already introduced and also explained very well also about the projects related to data internship analytics internship program. So I just request each one of you to please pay attention, and if possible, make notes, and make the most of this class, second last master class. Encourage your team members to join in, and she will definitely take us through the details of data visualization and machine learning in detail. So yes, so please pay attention and make the most of this. Over to you, Jayati ma'am. Yeah.
Hi, thanks for that. So let's just jump right into it. I'll start by sharing my screen. Uh, so maybe can you just stop sharing your screen so I can start sharing my screen, Anjali? Great, thank you. All right. So today I thought, first of all, this is a class in data visualization, so we will definitely be doing a lot of that. But I also thought that I will take you guys through the process of how we read data and the different things that we can just do with data in terms of data manipulation, and that in turn will help us to visualize our data better. And I'll be showing you a few different ways to visualize data and the kind of insights that we can try to draw from these visualizations, and everything in between. So all the different kinds of plots and different kinds of insights that we can get just by data exploration. And I've said this often enough, but really data exploration is a very very important part of any data science project, and a lot of your questions can simply be answered by really just exploring your data well and understanding your data well. So today our focus is on that. So we use 3 or 4 major libraries. Now, NumPy is a great library to, and it allows us to do a lot of manipulation with data, especially if we have, say, lists or matrices or things like arrays. And we will be using a little bit of it today, but due to the time constraints and how much we can cover meaningfully in 2 hours, we will not go in a lot of detail with NumPy. But I just wanted to show you that this is the page that you should come to for all things related to NumPy. And there is the documentation, there is the learn page, and you can learn pretty much most things that NumPy has to offer either on this page. So as you can see, they have a lot of tutorials here as well, or you can go to the documentation, and the documentation will also help you. So again, there is the getting started page, user guide, and API reference. And with all these three, you can pretty much do everything possible with NumPy. So I encourage everybody to look through these and see what the possibilities are. The second, and this is a library that we will be using heavily today, is pandas. And this is what lets us read data and do a lot of data manipulation in terms of what we want to do. So again, this is a great resource for everything pandas. Okay, you have the getting started, you have how to install it, you have the user guide. Okay, and again, anything pandas that you want, you will find it here either in the API reference or the user guide. And in fact, it tells you all the different things that you can do with pandas, right? And how to do it. So just anything that you might want to do in pandas, you can find here. So another great resource. And when in doubt, you should definitely come here and have a look at this page. Okay, next is data visualization. So there are two popular libraries that I often use. One of them is called matplotlib. Today, however, we will be focusing on Seaborn. So I just wanted to also show you the page for matplotlib. And again, this is filled with examples, different things you can do, different kinds of plots you can make, so on and so forth, including, as you can see, 3D plots. And it is an extremely useful plotting tool. The reason I am focusing on Seaborn is simply a personal choice, right? If you feel better with Matplotlib, you should totally use Matplotlib. Okay, and this is the page for Seaborn. So the reason that I'm showing you all these library pages is because I think it's very important for anybody who is just learning how to code to be able to come to these pages and really look at the documentation and be able to make use of the functions. So of course, I will be taking you through some of these functions that I have used often or that I think are very important, but by no means is that an exhaustive list. You can do so much more than I or anybody can cover in just 2 hours. So, this is a great place to get started and to understand. And even on a coding level, it's a great idea to always try to read these API references and the documentation to figure out what is going on. And you can always go to these tutorial pages for all of the different things that you might not just pick up from looking at the documentation. So a lot of people have just made these tutorials, and you can look at all of these and even get ideas on what you might want to do with your data. Okay, so this all of these library pages or package pages are amazing resources for you guys to check out, and I highly recommend that all of you check out these resources while doing your data science projects. Okay, so with that brief introduction, what I thought today we'll do is jump into a Python notebook and go over this. All right. So this will be really helpful for people who are just getting into coding or who are not from a traditionally computer science or coding background. And even for the people who are from a traditionally computer science or coding background, you can see the slightly more specific things that we use in data science. Okay. So you will always start with importing all the different libraries that you need. Okay, so that is what the first cell block here is doing. I have imported all the different libraries that I will want to use in this project or in this notebook. It is always a good idea and it is great coding practice to always have all your libraries that you want to use in one place at the beginning of your code. Okay, it just makes it easier for you to reference what you are doing and for other people to read your code as well. Okay, and it makes it everything a lot more organized. Now, in Python, what I can do is any library that I import, I can give it some name. So, for example, I'm importing pandas as PD. So, anytime I want to use the library pandas, I don't have to type pandas as a whole, module pandas. I don't want to type, I don't have to type pandas as a whole, though I can. I can just type PD. Okay, the same goes with NumPy, Seaborn, Matplotlib, so on and so forth. Now, let us start with how to get data into our working environment to actually start working with it. Some great practice data sets are often built in some of the Python libraries. So tips is one such data set which is already built in. And how do you use a built-in data set? There is a function called load underscore data set. Okay. And here what this command is telling me is from SNS. What is SNS? SNS is Cbond, load the data set. So load data set is the function that I want. Where do I want to use it? In the library SNS. And which data set do I want to load? That data set is tips. Okay, so let me just run this. Okay, so that imports all my libraries and this imports my data set. So very quickly, let's just see if it actually imported it. Okay, so it has imported some data set, right? You can also make your own data set. So for example, here I have something called data. Okay, and essentially I can do a dictionary like construction and I can say, okay, for some data that I have, I will just manually enter everything. So for example, I have college and college takes the values A, B, C, D, E, F, G, H, and in each college I have some student count. So this is how many students there are in each of the colleges, and I have a average grade for the students. So again, this is a totally made up data set, but that's what I'm going for here, right? And this is perfectly okay as a data set, right? So let's just see. This is what the data looks like. Now, for the most part, you almost always want to work with a data type called a data frame. Okay, and it is very well suited for us to work with this kind of data frame simply because there are a lot of nice functions that we can call and use when we are working with data frames. All right, so to put it simply, it sort of makes our life easier. Okay, so how do I then go about making a data frame. Let's say I have data which is in this form, right? This is a data type that we have discussed before. I can convert it to a data frame. How do I do that? There is a command data frame, okay, and it's case sensitive, so be careful here. So and it lives in PD. I call this command pd dot data frame, okay. I tell it what data it needs. I give it column names, okay, and I give it how to index it, and then I just try to print it. Okay, so when I run this, what happens? Do you notice something different has happened? So here in my data, I did not have a column fees, right? However, when I was making the data frame, I added a column fees and I didn't give it any values, right? So by default, what it has done is given the entire column non values, okay? So I could just remove fees and then I get my original data. However, if I want, I can add columns to my data set here. Okay. So this is how that works. Okay. I can add columns in other ways as well. For example, let's say I wanted to add a column called capital. Okay, could mean anything. So I say df of capital. Okay, so whenever I write df square brackets with a string in it, it means I am referring to some column in my data frame. And what does this mean? This just means empty. Okay, so this just means empty. So when I do this, what will Python do? Python will create an empty column which will be titled capital. Okay, note that these are not NaN values. This is just an empty column. It doesn't have anything. Okay, here when I added a fees column in my data set, it gave the column some values and those values were NaN. Okay, but over here I'm creating a empty column, and so Python will not add any values in this column. Okay, so hopefully the difference is clear to you all, and how you can potentially add columns to any data frame that you have. Okay, now let's say I did not want this column to be empty. I wanted this column to be say NaN. Okay, then what I can do is I can give it some values, and this actually comes from NumPy. So again, we will not cover NumPy in all of its detail today, but it gives you, arrays of arbitrary items, all right, and it is great for doing some really quick mathematical operations over arrays. It also gives you a lot of functions from linear algebra, and this is also what you can use to generate random numbers if you ever need to. And again, more information available on the web page, so please go through that. Okay, so what do? I use np.nan, and nan here becomes a data type. Okay, so then when I say df of capital is equal to np.nan, now I'm not creating a empty column, which is what I had done here. Now I'm creating a column that has nan values. All right, and so you can see that in the capital column, it's not empty anymore. It does have NaN values. Okay. The reason I'm using NP is because it gives me a way to do this array business, and it gives me NaN values that my DF can also work with and recognize. Okay. Now, when you have your data set, you can try to locate certain things within your data set. Okay, and how do you do this? You do this by the function lock. Okay, so let's maybe try a simpler lock if it works. All right, let's see, df.lock 2. So what does this do? The first thing that I give it is the index. Okay, so what has lock done? It went to the indices. It found 2, and it gave you all of the information about this row. So it is telling me that at index 2, the college is B, student count is 2001 students, average grade is 4.7, fees is NaN, and capital is empty. Okay, here is a question for you. Why is it that even though over here I have the capital column as NaN, when I said DF here, I have the capital column as empty? Something for you to just think about a little bit. Try to think why this happened. Okay, now what I can also do is, let's say I want specific information about the index 2. Okay, so maybe I just want to know for index 2 what is the average grade. So I would type average grade, and now it only gives me what I have asked. Okay, so I can also locate or identify specific information about whatever index I want. So potentially I could add, say, one more thing, right? Okay, the other thing you want to remember is, as you type these strings, these are strings, so they are case sensitive, and you have to type them exactly the way that the columns are named. For example, if I just changed the case here, it gives me a key error. And if I scroll all the way down, it gives me a key error, AVG grade, which just means that it does not know what to do with the string that I have given it. It does not understand this key. Okay. So in this case, you have to be a little careful, and you have to type the column name exactly as it is named. You cannot mess around with the names themselves. Okay. For example, I can't here type capital T. Okay. And again, I get a key error. All right. Okay. I can do something similar like we did with series and ranges in Python earlier. So I can say, okay, give me everything till the index 8, and it will then give me, or it will run through everything till index 8. So if I just do that, I just get my entire data frame. Let's see, let me try 3. So now I just get the 3 columns. Okay, I could say everything from 1 to 3, okay, or everything from 2 to 5, okay, and it has now given me all the indices from 2 to 5. Okay, so I can keep asking for more specific information as well. So I can say, okay, all of these indexes, but I just want the college. So it only gives me the college. Okay. All right. You can also compare things. You can use logical operators. You can use mathematical operators while trying to locate something. So Let's say I want to locate all the colleges which have grade greater than, say, 3. Okay, how would I do that? So again, I would use df.lock, and I would say, okay, locate everything such that in my data frame, look at the column average grade, compare this average grade to 3. If it is greater than 3, okay, then locate all such columns. And when I do that, you can see that it has located all the columns where the average grade is greater than 3. Okay, so I can say do maybe 4, and then I see that it's 4.7. I get only one college. Okay, you can also compare things. All right, so for example, here I have, okay, give me all the colleges such that the average grade is equal to 3.2. So when I run this, I get the colleges whose average grade is 3.2 exactly. Okay, so you can use such operators and also try to locate things in your data frame. Okay, and sometimes it might be that, maybe I want to have, say, I had, maybe a few more features here and a couple more colleges here and so on, and maybe I just wanted to look at features of colleges which had grade equal to 3.2. So often what I can do is I would say, okay, create another variable. So let me call it df3, and that be equal to all of these. Okay, so then if I just type df3, I get these two colleges. The good thing or the added advantage of storing this in a variable is that I can now also deal with just these two colleges if that was my requirement. In case I did need to look at all the colleges, I just needed to look at the colleges which have grade 3.2. Now I have them stored in a variable and I can do the data manipulation just within this variable. Okay, and just see if I can check the type of df3. So you can see that it is still a data frame. So everything that I could do with df, I can now also do with df3. The added advantage is that this is a much smaller data set and I can look at the features of just this smaller data set, which might be of a higher interest to my problem. Okay, all right. Then there is a similar function which is called ilock. Okay, the difference between lock and ilock is that lock allows you to locate columns which have greater than 3. Okay, and then I just get the 3 columns or 3 rows that I wanted. So again, this works with all possible things. So you can do that, or if I just did 2 colon, it would go till the end. Okay, so on and so forth. Okay, so this is some basic stuff that you can do with a data frame, and in this case, what we
Hello,
had
ma'am.
done, yes.
Sorry for the interruption, but your screen is not visible to us.
Oh,
For the last 2 minutes, your voice was not there and your screen was not visible.
okay. I'm sorry about that. Is it visible now?
Yes, ma'am.
Yeah, ma'am.
Perfect. And I assume you guys can hear me. So, did you get the df.lock function, everyone?
Yes, ma'am.
Okay.
From my
So,
desktop.
Okay, I'll just start with df.log again. What df.log does is it locates the variables of your interest. All right. So you give it some kind of condition or interest category, and df.log will locate those rows from your data frame. So that is what I have done here. So for example, if I just say df.log,
Excuse me, ma'am.
yes,
Ma'am, we were at code number 26, I guess. This part we have done. We were at code
26.
number.
Okay, perfect.
Sorry, you can continue, but 24 also. Yeah. Yeah.
Okay, so again, what has happened here at df3 is equal to df.log, df average grade is equal to 3.2. Okay, what is equal to? It's just comparing, right? And this will give me all the colleges where the average student grade is 3.2. Okay, and the added advantage of storing it in a variable is that now I can look at this smaller data set, which might be more meaningful for my analysis of my question. Okay, and if I try to look at its type, you can see that it is a data frame. So everything that we did with df, we can now also still do with df3, and this is a smaller data set. Okay, so that is the added advantage, and it can come in handy at times. Okay, the other thing that I can do is the other way that I can slice or get specific rows from my data frame is using the function ilog. So far we were using log. Now I'm going to use ilog. And what ilog does is you can give it an integer value, and accordingly it will locate that integer on the index and give you the value. So for example, I can say df.ilog 2, and so it will give me the all the information of the second row. Okay, or I can say df.ilog colon 2. So here it will give me the information till 2. Okay, so this is something that we have seen before with series and so on. So if I say 2 colon, for example, it will start from 2 and go on till the end. So these are some of the different ways in which you can locate specific things in your data frame, okay, depending on your need. And you can form a data frame. You can figure out how to add a column to your data frame. One other useful feature is concat, so that also lets you add column or columns to your data frame. Maybe try to look it up. Okay, so this was generated data that I constructed manually, and it had just 8 values. Now let's look at a slightly bigger data set. This data set I already imported from SNS. All right. So this is the data set that I imported from SNS, and now let's try to look at this data set. So I can just print the whole data set. Okay, so it will not print the entire data set here, but it will show me what it kind of looks like, and it will also show me how many rows and columns I have. So I have 244 rows and 7 columns. Okay, and this is a nice data set for a lot of visualization things. So let's just look at what this data set is and the columns that it has. So the first thing is total bill. Okay, so it seems to suggest that some kind of shopping has taken place or some kind of service has been charged. Then it tells us how much was the tip for that bill. Okay, then it tells us what the gender or sex of the person was who made the tip and who paid the bill. We also get to know whether said person is a smoker or not. We have data about on which day it happened. We have some information about what time, so whether it was dinner or something else. And we have the size, which in this case means the size of the company. So whether it was 2 people, 3 people, 10 people, 100 people, so on. Okay, so this is basically a data set for how much a customer tipped at a restaurant. Okay, and whether this customer was smoker or not, on which day it happened, which time, and who paid the actual bill along with the total bill amount. Okay, now if I wanted to make it into a data frame, uh, right, all I have to do is just type the same thing, df. So in this case I'm naming my data frame as df tips is equal to pd dot data frame. Okay, all right, you can get a lot of information from such things. So for example, if I just wanted information on what the column names are for my data frame, right, without maybe printing it, or sometimes it just makes it easier to have it in an index like this, I can type dftips dot columns, and this gives me all the different columns that my data frame has. Okay, now notice that all the different columns have different kinds of data, right? Here I have some numbers, whereas sex, smoker, day and time are not numeric data, right? So this is what we call usually categorical data. And then size is again numeric. So I can get information about how Python has stored these data types using the function called d types. Okay, and once you have this, if required, you can also change the type of the data in case it is required. So you can explicitly tell Python change this data type to something else. It is a possibility. However, if you just wanted information on what types of data in terms of what Python has done, you can just use df dot d types. Okay, now once I have some sense of my data, there are a lot of different things I can do with it. For example, I can check if there is any null values in my data. Okay, so how do I do that? There is a function called isNA which checks for all NA values in your data frame. However, if I just type okay. So if I just type dftips.isNA, isNA actually returns a Boolean function. So either true or false. So it goes through every cell of my data frame. It looks at the value. It checks whether it is null or NA or not, and returns a true or false. So for example, the first cell in my data set is 16.99, which is not NA. So it has returned false. However, this does not really give me a lot of useful information, right? Just by looking at this output, I don't know whether my dataset really has NA values or not. So what I usually do is I will say dot sum. And what does this do? It will just sum up every column. Okay, but how does it sum up false and true? Remember, these are Boolean variables. So false is 0, true is 1. Okay, so when I do this, it will just sum up, and each false is 0, each true is 1. So if I get all zeros, that means that all of the cells in my entire data frame were 0 or false. So this means that there are no NA values in my data frame. In case I had, say, 1 here in day, that would mean that I have somewhere in my data frame a day value which is NA. Okay, all right. It often also makes sense for us to check random parts of our data. Okay, because if, let's say, I look at just this, and you can see that so many rows in the middle are just hidden, I might think that, okay, all the time that the uh, data was collected was during dinner time. Okay, so it is sometimes nice to check whether check a random sample of your data, and that can be done by data dot sample. So you can either say tips dot sample, or you can say df tips dot sample, and this 5 tells you how many samples you are asking for. So when I write 5 or when I type 5, it's going to give me 5 samples, and every time I run it, I am going to get different samples. Okay. The other thing that you can sometimes do and can be very helpful is the head and tail function. So df tips dot head, and this shows you by default the first 5 rows of your data set. Similarly, the tail function by default shows you the last 5 rows of your data set. However, if you wanted more or less, you could explicitly tell Python how many you want. So if I type 3, it's just going to show me, excuse me, it's just going to show me 3. If I type 10, now it will show me the first 10 rows. Okay, so this is some very basic data exploration, and this is how you kind of start to make sense of what your data has or how it looks, and you start to get a sense of what your data is doing. Now, before I move forward, I want to also mention one other way that you can get data into your Python environment that you're working with. So the first way we saw was how to, if you just have your data that you're typing in manually, you can just create a data frame, right? Often that will not be the case, and mostly all of your projects will also not be projects on the training data sets that are inbuilt in Python. A lot of your data sets will actually be in a .csv file whenever, if ever you are working with structured data. Okay, so .csv is kind of like your Excel file. Okay, and it's basically a table and it has all these things. So you can, in case you have a .csv file, how do you get that into your Python environment? You say, okay, I'm creating a new data set, I'm creating a new variable. So I say df underscore missing pd dot read csv. Okay, and in fact there are other things that you can do. So you can read csv, you can read excel, json, html, so on and so forth. You can read a lot of different kinds of files in here using pd.read underscore. Okay, and then adding whatever your file type is. So very often CS and Excel, in case you are having structured data, and within the brackets and within these single quotes will usually be your entire will usually be the file path. The reason here I don't have an entire path is because both of the my Jupyter notebook and this dataset lie in the same folder, but it is better to have the entire path when you are working with it. So something like you can usually just copy the relative path and then paste it here. Okay, so that is how you can get these path values. So just wherever your data lives, okay, or whatever you want to get to your Python to read. So for example, let's say I wanted this data set, I would say copy path, okay, and I would say pd dot read csv, and I would paste the path. So in this case, what it has done is it has pasted the entire path. You can also say paste a relative path, and that will also work. So here I have some data set which I am calling tips missing values, and in this case I have made a few values missing. So let's just look at df missing dot head, and let's look at the first 10 values, and you can see here that I have a bunch of missing things. So I have na, nan, not applicable, null, and some of them are numbers, right? So when I do df missing dot is na dot sum, it will tell me that I have missing values. And where are these missing values? Some of them are in the total bill, okay, some of them are in the total number, but what you see here in table number, but what you see here is that in table number I have a lot more missing values than just na, and somehow it is showing me only 4. The reason is it's only checking for na values. It didn't care about the nan or the non-applicable values or the null values. Okay. So in this case, what do you do? How do you get hold of all of your missing data? Okay, so this is just the head again. So what I can do is I create a data, I create another array or list, and I say, okay, na values are na and null, and while reading, I give this information to my pd dot read function. So now when I read this, I have that it replaced the na and null values with nan. Okay, so now if I do df dot df df na dot is na dot sum, you will see that it behaves better. The reason that it's still not getting all of them is because I did not change not applicable. Okay, and we haven't looked at the entire data set, so who knows, maybe there are some other things that we should have changed and we haven't. But in general, this is one way in which you can change these values. Okay, there are others, so we will look at them. So whenever you have these string data types, you can manipulate it and you can change it through the entirety of your data set using such functions. Of course, you can try writing loops for these, but there are also inbuilt functions which allow you to do this work. Okay. All right. So let's look at some other examples which allow you to play around with these values. So let's see. If I just want to look at maybe one column of my entire data frame, I can call just that one column. How do I do that? I say df, I put square brackets and the column. Okay, so df of sex, and it gives me the entire sex column. Let's say I want to play around with these values now. Okay, how can I do that? What are the different things I can do? One thing I could try is something like string lower. So what does this do? uh, okay, 5 to 20. Okay, so for some reason, the issue that we're facing is it's not recognizing sex in my data frame. Let's just see. Okay. Okay. So the issue is that I have the wrong data frame actually. So when I do dfna of sex, now it works, right? So in df it did not. The issue was that I did not have the right data frame. So sorry about that. Okay. So now if I do this, right, you can see that everything has become, or everything has gone to lowercase. All right, so this is a change that I made in, or that I'm one way to play around with these values. However, look at what happens now if I just print dfna, and you can see that in fact in my dfna this is still the first letter with uppercase. So the reason that has happened is because I asked it to change the string to a lowercase. However, I did not ask it, or I did not give it permission to actually go to my original data frame and make any changes. Okay, so these changes will just stay in this cell block here, and once I return to my original data frame, these changes would not have been made there. So one way to make changes in your original data frame is just by overwriting it. So you say dfna is equal to dfna of sex dot str dot lower, and this will change your original data set. Okay, all right. Now the other thing that you can do is you can use a function called replace. All right, so let's see how that works. So let's say that I look at this column again, and say I want to replace all, everywhere that female comes, with the number 0. Okay, so what do? I say, okay, I start with my data frame. So I say dfna, which is my data frame. Then I tell it which column am I talking about. So I'm talking about sex. What do I want to do? I want to replace something in this column, and this is just telling me the uh, how this function works. And you should always try to read the documentation regardless of anything else. Please always try to read the documentation of the functions that you use. Okay, so I tell it to replace, and then I have to give it what I want to replace. So I want to replace female with 0. Okay, so what I want to replace and what I want to replace it with. Okay, so when I do this, I have that all of the females entries have now been replaced with 0. Again, note that this has not changed my original data frame. So if I said dfna dot head first 5, I still have female here. Okay, if I wanted to change it in my original data frame, okay, one thing is I already described, you can rewrite it. The other thing you can do is you can say in place is equal to true. And what this does, writing in place is equal to true, means that now you are telling Python that you want to make these changes in the original data set. So let's just see what happens. Now you can see that my original data set itself, or my original data frame itself, has changed. So these are the two ways in which you can change the original data frame that you're working with. All right, you can either rewrite it or you can say in place is equal to true. Okay, so now we have some sense of, okay, if I have a data set, how can I do different things? So you can replace, you can change things, you can even drop values. So the function for that is df dot drop. Okay, so that would look something like dfna dot drop, and then there are different ways of dropping things. So you can drop, and then you can tell what you want to drop. Okay, you can say drop duplicates. So in case Python parses through the data and finds any duplicates, it will delete the duplicates. You can say drop na. So in this case, it will go through your entire data set, and wherever it finds an na value, it will remove that row. Okay, again, be careful when you do something like drop na and you make in place is equal to true, you will change your original data set. All right, so these are different ways that you can start by manipulating your data to clean it and make it in a form that is more acceptable to whatever it is that you are doing. Now let's get to how or what are the different functions in Python that you can use to actually gain more information about your data. So one of them was already we looked at D types, and this just tells you what data type is your data stored in. Okay, so the data types of the individual columns in your data frame. There is a very helpful function. It is called df or it is called describe. So when I use this, it will tell me all of the different statistic values for the different columns in my data set. So when I just say df, this was the original data set that we had for the average grade and so on. So you can see it tells me count. So how many things I have, the mean for everything, the standard deviation, the minimum, the maximum, the 25%, 50%, 75%. Okay, so we can try it for other things. So I can try it for df tips. Okay, now you can notice something different happened. What is the difference here? You have in df tips, so let's just load df tips for reference. Okay, so you have in df tips a lot of categorical variables for which things like mean and standard deviation don't make much sense, right? You cannot find the mean of a bunch of no's and yeses, or you can't find the mean of Sunday, Monday, Tuesday, Wednesday, so on, right? So when you do dot describe, it will only take the numerical variables that are available to it, and it will give you different statistics of those numerical data. Okay, for example, I can already see that the highest bill ever was 50.81. Okay, the highest tip that anybody ever got was 10. The maximum size of a party was 6. I can similarly get the minimum. Okay, I can get mean, I can get 50 percentile, so on and so forth. So this already gives you some idea of what your data looks like. The other thing that you can often do, and is a great function, is the dot info function. So this already tells you a bunch of information about your data. For example, it tells you how many columns you have, which are those columns. It will tell you how many non-null values there are, and it will tell you the data type for all of your different columns. Okay, all right. You can manipulate specific columns as well, like we discussed. So for example, if I just wanted the mean of the total bill, so what would I do? I would say df tips. So that is the data frame I want. I will tell which column I want to look at. So I want to look at total bill. And what do I want about this column? I want the mean. So this gives me the mean. I could say that just sum everything up. So it will just sum everything up. Okay. And what are the different cases it can go wrong is where you give it something that it cannot do. So for example, if I say df tips 6 dot sum, now it cannot sum up the sex because that was a categorical variable. These are not numbers. So then it gives you a type error. Okay. Okay. You can also play around with the data types, and one way to do it is using the as type function. Okay. The other great function to sometimes use and sometimes comes very handy is something called value counts. Okay, so what does this do? It looks at all of the different values that any given column can take, and it counts those values. So for example, here I say, let's say 6. Okay, so df tips is my data frame. The column I want to look at is 6 and value counts. So it will look at all the different values that sex can take, which is male and female, and then it counts how many times the male occurred, how many times the female occurred. So similarly we can do it with time. So now I can see that there were just 2 times, dinner and lunch, and dinner occurred 176 times, lunch occurred 68. Okay. So these are the different ways you can look at how many times a particular value occurs in your in some column that you are interested in. Okay, you can also look at all of the different unique values that occur in any given column, and the function for that is unique. Okay, so this just gives you a list or array of all of the different unique values that that column can take. So for example, if I type uh, mm, here right? Huh. So in this case, it doesn't know what tip is. All right. So I can say, for example, time, and then it will give me that time has two unique values. Okay. All right. Then, if you wanted, you could change these variables depending on your convenience as well. So, for example, again, if I look at instead of time, if I look at day, I can see that the values that day can take is sun, sat, thur, and fry. And maybe it's not the best for my users that I have these abbreviated day names. So maybe I want to make it so that these day names appear in their full. Okay. So what can I do? I can say, okay, I can map these values to my desired values. So what do? I use a function called map. So again, I start with what data frame I want. Then I tell it, okay, within this data frame, which is df tips, look at the day column. In this day column, do something. What do? Map. How do you map it? You map every Saturday, every Sat to Saturday, Sun to Sunday, Third to Thursday. Okay. And when I do this, this is what will happen. Okay. So in this case, Fry will remain as Fry. All of the other days will change according to what I have just mapped them to. Okay. So this can be very useful, especially in cases where it becomes more convenient for you to name things a certain way while you do your analysis, or sometimes better for presentation purposes when you have to present it to somebody else. Okay. All right. So value counts we already discussed. Info is also something that we already discussed. Okay. So this is sort of, now you're getting into how you can get some sense of what your data has and start to manipulate your data values. Now, once you can do all of that, we can start to visualize our data. Okay. Because remember, with an unclean data, you will not be able to even visualize it. So once you have all of the tools that you require to clean your data, you can now start to visualize your data, and that is what we will focus on going forward. And I will also try to introduce a few more useful functions that we have in Python, which also help us in data analysis or exploratory data analysis. Okay. So primarily I'm using CBond, which I have as SNS. Okay. So one really nice plot that you can often fall back on is something called the rel plot in SNS. And here it's just a simple scatter plot. Okay. So I say I want to know the relationship between the total bill and the tips. So I say, okay, x-axis take total bill, y-axis take the tip, and which data will you use? Use the tips data. Okay, and I run this. And so I get this really useful looking plot which shows that there is a positive correlation between the total bill and the tips, right? This does show me that as the amount of the total bill increases, more or less the amount that was tipped also increases, right? And this is how, by looking at such plots, you can start to form your hypothesis for whatever it is that you are modeling. You look at such relationships and you look at how your data is, and you start forming your hypothesis which you can then use to make predictive models or to test your insights. So this shows me that, okay, yeah, with a higher bill, chances are that the tip also increases. Okay, and I do see some level of positive correlation between total bill and tips. Okay, now I did have a lot of other features in my data set, and maybe I want to see how they affect also my tips, right? So in this case we are focusing on, or as a data scientist I am focusing on the variable tips, because I want to know what features actually help me getting higher tips from customers, right? So that can give me some actionable, potentially actionable insight, right? Okay, so one thing is, if they're spending more they will tip higher, but what other things are affecting it? Is it possible that males always tip higher than females? Is it possible that females tend to tip higher than males? Is it possible that people tend to tip higher when they come for lunch versus when they come for dinner? Do my tips increase on a specific day? Right? These are all questions I can ask, and I can try to check if there is any weight to these questions using such data visualization. So let's look at some of them and see what kind of insights we can come up with. Okay, so there is a really nice feature in Seaborn which is called hue. Okay, and we will see how it works momentarily. So again, what do? I say, okay, I still want total bill on my x-axis. Okay, I've already noticed a positive correlation there with the tips, but now let me see how many of these guys were smokers and how many of them were not smokers. So in this case I can use something called as hue in SNS, and I tell, okay, for hue use smoker, and for data just keep it tips. And when I plot this, what it has done is it has given two different colors to the two possible values that the column smoker can take. And now I can start to maybe formulate some more hypotheses, right? I can say, okay, from this it looks like non-smokers often pay more tips, higher tips, right? So I have, for example, more non-smokers beyond 6 than smokers. So maybe it's possible that smokers pay higher tips as the total value of my bill increases, right? So this is another hypothesis that I can form now, and I can start to think, oh, maybe how much a person smokes, or if a person smokes or not, also has a lot of effect on how much tip I am going to make from whatever they spend, right? Similarly, I might want to think about, oh, does the sex of the person have any effect on it, right? So that is the next scatter plot that we have. So again, X and Y stay total bill and tip, but now I change U to sex, and my data will just stay tips for the purposes of this data visualization exercise. Okay, so here is the data on how much was the total bill versus the tips, but I can see which of these people were males and which of these people were females. And now I can start to make another hypothesis, right? What can the next hypothesis be? In general, where I see males and females, right, which is mostly this region here, I see that they pay almost equivalent amounts of tips. But I also do not see a lot of females who are spending, say, over something like 35. So from this, I can tell that, okay, probably the sex of the person does not affect how much that person might tip, but it looks like in general males might be spending higher totally than females, right? So these are all different hypotheses that we can start to make once we start having these data visualizations. Okay, so this is not something that we might have guessed just by looking at a giant table of data, but now with data visualization we can start making such guesses. Okay, all right. Here I have just one more style. So this is just a stylistic choice, which is something that Python and SNS allow you to do. So in this case, you can see that I have X and crosses in two different colors instead of two dots of two different colors. Okay, so this is just a stylistic thing that you can do in case you want to. Okay, all right. So now let's look at something else that we can do. I can say, okay, X be the total bill, Y be the tips, Q be smoker. So whether the person smokes or not. But I also want start to figure out what relationship this has with time. So I say something like style is equal to time. Okay. And when I run this, I get this plot here, which is now telling me much more information, right? So it tells me that, okay, um, which are the smokers and non-smokers. So the blues are the smokers, the oranges are the non-smokers, but it is also giving me some information on the time. So it is telling me that if it is a dot, it is lunch. If it is a cross, it is dinner. Okay. So I can see that generally more spending happens at dinner than at lunch, probably. Right. And so these are all the different things that you can start to play with given whatever data you have. And I highly recommend that everyone goes back to the documentation pages and the API references and the tutorials of these Python libraries and have a look there, because they will have these in much more detail. But so you can, the idea here is that you can start adding on or layering on information into a single plot in these different ways, right? So this tells me that, okay, more is spent on dinner and probably by non-smokers, right? Or more tips are given by non-smokers during dinner. All right. So things like this are the kind of guesses and insights that you start to make once you start to explore your data. Okay. What other kind of uh, data can I generate? What other kind of graphs? So again, for example, I can look at the size of the party, right? And you would think that there is a correlation between the size of the party, the bill, and the total tip, and you can see that that is mostly true, right? Singles or people who comes in twos or threes spend not as much and tip not as much. People who come in larger groups spend a bit more and tip a bit more, right? So this is also something that you are able to see with this plot here. And let's just quickly go over the different parameters, that arguments that I have here. So here again, all of the same arguments, I have added a argument height, which is what is giving this graph be this large. So I can manipulate it. So let's just try to do that, and now you can see that this is a much smaller graph. And all of these graphs that you make, you can save them as is. So you don't have to go through the trouble of you know uh, taking screenshots and whatnot. You are able to save these graphs. So if you're using a Python notebook, chances are that you have something like this, these three options that show up. So you can copy it to clipboard and paste it wherever you want. Okay. You can expand this image or you can just save this image. Okay. And you can just name it whatever you want. So build versus size, say, and then it will just save that image as a png for you to use later on. Okay. All right. Okay. And then you can try to play with how the visuals of the graph itself form. So for example, here I say that as size increases, I want Python to change the the size of the dots that I have on my graph. So that is what I have done here, right? Okay. Then what you can also do is you can have these charts be present in multiple charts being present in the same row, or have a few columns of these charts. And what this helps you do is this helps you compare similar things. Okay. So for example, if I wanted to compare lunch versus dinner, so that is what I have done here. So let's look at again the parameters. I have the total bill on the x-axis, I have tip on the y-axis. I am looking at smoker behavior, but I try to see how or if it differs in time. So I make two charts, one for lunch and one for dinner, and I color the data points using whether the person is a smoker or a non-smoker. So when I run this, you can see that I actually have two different graphs now, okay, which show me how the behavior is at lunch and how the behavior of this population is at dinner. So right off the bat, I can start to see that probably way more people come to this restaurant for dinner than they do for lunch. Okay. You can also see that more smokers join in for dinner than they do for lunch, right? And you can see how the tipping varies between smoker and non-smokers during lunch and dinner, right? So a person is way more likely to make a really high tip during dinner than the person is to make during lunch, right? So this is a kind of insight that might be actionable for you if you were a person who wanted to make higher tips, right? Then you would try to get more shifts during dinner than during lunch. So these are the uh, things that you can also start to do when you want to compare similar things, right? So here I wanted to compare smoker behavior, but I wanted to do it in different times, so lunch and dinner, not as a combined thing. All right. So similarly, okay, all of this we can do using data visualization. We can also do it to some extent without data visualization, just in a exploratory way. So how do we do that? There is a really cool function in Python. It's called group by, and it really comes in handy when you're trying to figure a bunch of these things out. So for example, I say tips, which is my data. So df tips will also work, and I say group by. Okay, this is telling me what I want to do. I want to group something. How do I want to group my data? I want to group it by time. So what are the different values that my time can take? It can take lunch and dinner. Okay, so I will group by time, so take lunch and dinner. In these groups, look at the column total bill and give me the mean. This is what this function is telling us. Okay, and so you can see that the total mean bill during lunchtime is 17.1686, and during dinner is 20.797, right? And this also gives you an intuition as to when a person might be getting higher tips, or on the other side, when a person who is coming to your restaurant might be spending more, right? So this gives you a sense of that the fact that there is a difference between lunch and dinner, and also you can see it visually that there is a difference between how much people spend during lunch and how much people spend during dinner. And you can use these group buys in a lot of different ways, however you want. So for example, if I wanted to say look at tip, I could do that, right? So the average tip that a person made during lunch was 2.728, whereas the average tip a person made during dinner was actually 3.1. So again, these are ways that you can start to form intuitions and theories about what your data is telling you. Okay, now maybe it's a possibility that, okay, they make or people spend more during dinner. Do people also spend more during certain days of the week? So let's try to do that, right? So then what do? I say, okay, group by day instead of time now, and tell me the mean of the total bill on each day that is present in our data. And so that is what Python has done now. And you can see that on average, we have a higher amount of spending on Saturday and Sunday than when we compare it to Thursday and Friday. So this is another hypothesis I can make, or another insight I can have, which tells me that on the weekends, Saturday and Sunday, the average spending will be more. And if I am to believe that, a higher spending comes with a higher tip amount, then I might want to take shifts. If I want to maximize how much I can earn in tips, I might want to take shifts on Saturday, Sunday during dinner time, right? So again, just an example of the kind of insight that you can try to make using data exploration and data visualization. Saturday and Sunday. Okay, I hope my screen is visible now.
Yes, it is visible.
Okay,
Yeah.
perfect. Okay, so can I try to figure this out using data visualization as well? Yes, I did it here as columns, and I can do it similarly, right? So let me see if the sex makes a difference. So I would say, okay, I know that smokers spend more, so let that be there. And then for the column, I will say, okay, make one column for males and one column for females, and let us see how they relate to the spending and the tips, right? So again, I can start to make some kind of deductions here. For example, I can start to say that, okay, maybe males tend to spend more than females do, right? Also, I can see that there is an unbalancedness between the number of males and females who are coming out, right? And how much they spend and how much they tip. So this is giving me some information about that, right? And of course, I can just again try to check using group by and see how far my intuition is true just by looking at these graphs. And I can see that, you know, On average, males are spending 20.744 on the total bill, and females are spending about 18.056 on the total bill. And of course, I can, if I want to, do this for the tip received as well. So you can see that on average, a male tip is 3.089 and a female tip is 2.8. And see, when I look at this, it might be that I might think that, that difference is very low, but there is a difference. So then I can think of trying to check whether this difference is statistically significant or not. So this is also where some of the modeling will come in. I can make some type of statistical test to check whether males really tip higher, right? Or I can, try to just model and see what the model predicts for a tip by a male versus a tip by a female, so on and so forth. So that is where some of the modeling comes into play, and this is where I'm making my hypothesis and trying to get an intuition of my data. Okay, so again, I can check by different days as well, and here I can clearly see that when I have it for different days, I have that there is more spending on Saturdays and Sundays, and also a lot more people coming out on Saturdays and Sundays. And in fact, I could maybe even go as far as to say that the fewest number of people come on Fridays, right? And again, that is just a hypothesis, and this is something that we can then in our modeling phase try to check or validate and see how the model plays out, right? Okay, and then I can just see by group by, and I can see that actually the total bill on Thursdays is about, see, this is a dot count. So this is telling me how many people came, right? Or how many counts of total bill there are on given days, right? So this is what that is giving me, right? Okay, so for example, I could just check mean, and then this will show me something that I've already seen before, right? So when I check for count, what this is doing is showing me that on Saturday and Sunday there are more people coming, and on Friday I have the least amount of people coming in for eating out or dining out, right? So again, different insights, like maybe if somebody had to take leave, Friday would be a great day for me as a business owner to grant this person leave, because I know that not a lot of people are going to come in anyway, right? Or if as a person I am thinking of which is the day I should take shifts to make the most amount of money, then I can say that okay, maybe Saturdays and Sundays, right? Okay, then you can do this very similar thing that we did with these columns here, but I can say okay, instead of having so many columns and doing it that way, I can make something called a cat plot or a category plot, and here my x-axis becomes the category that I'm looking at. So in this case, day, for example, and then I tell what my y-axis is, which is the total bill, and I look at the uh, you know tips data. So this is what that looks like. So I can see that again, total bill on Saturdays and Sundays is higher, right? Total number of dots on Saturdays and Sundays is higher. So it does show us the different trends that are going on. And of course, you don't have to stick to bill. So for example, I could say tip, and now it shows me how much tip, and I can see that in fact on Saturday was when people got the most amount of money with tips, right? And you can again start to layer more information on such a cat plot by using things like Q. So that is what we have done here, where I have a category plot. So I try to represent what is happening on different days. I look at the total bill on these different days, and I can point to the sex of the person, whether they are male or female. So I can start to look at how many males are coming out versus how many females are coming out, and if that has anything to do with the day on which they are coming out, and again, who is spending how much, right? So again, you can change this to reflect what you are interested in. For example, I can do this, and now it tells me how much tip was earned on any given day, right? And whether the person who was tipping was a smoker or a non-smoker. All right. Okay. So these are the different ways you can build such category plots, and you can then also try to make them stylistically how you want, and cbond gives you a lot of different ways of doing that. So this is just one way of making a stylistic choice. Okay. All right. A swan plot is very similar to a cat plot. The difference being that in a cat plot or in a plot like this, you are very okay with data points overlapping, whereas in a swan plot you're not so okay. So in swan plots you will see that the data points don't overlap, and one advantage of this is potentially it tells you in a clearer way where or in which part is the frequency of people more than other parts, right? So just by looking at how much these spread, I am able to tell which kind of people frequent, or which is the most frequent category of people. So for example, most people who come in to restaurants will spend around, say, somewhere between 10 and 20 dollars or rupees, depending on where this data was collected, right? So just by looking at the spread of the points, I am able to get this insight, right? Okay. And then again, you can do all of the same things. You can check hue, you can make them more or less opaque. All of those things are still always possible in a swan plot. Okay. Now, we have been seeing that we can add such layers to such layers of information to our visualizations, and we saw that at least some level of it is possible when I use a group by. So can I also use group by to have such layered information? And the answer to that is yes, indeed I can. So for example, I can ask it to group it by day and sex. Okay. So then it tells me on Thursday, the total bill count for males was 30. The total bill count for females was 32. So on Thursday, there were more females than male, or you could say maybe almost equal, right? On Friday, also almost equal. On Saturday and Sunday, way more males came out than females did. So this is another kind of trend that I am able to now find by adding more layers to my group by. So let's just go through this function once and see what it is saying. I'm saying look at the data tips. Okay, group this data. How will you group it? Using day and sex. And in this group or in these groups, what do I want to know? I want to know the count of the total bill. Okay, and again, you can change this. You can make it say mean of the total bill. And this tells you on average how much did each group spend. All right. Okay. So this is how you can also use group by to layer more information and potentially get way more insights about your data. So all of this is part of your exploratory data analysis and will totally depend on what kind of questions you are interested in, and also what kind of questions you can think of where you might think, oh, this might lead me to an interesting insight or theory to my data. Okay, so again, swan plots we have discussed, right? And you can do this in many different ways. So for example, here I have the size and the total bill, right? So this is great because I can see that most of the time I have that people come in sizes of two. So there are pairs of people who are visiting, and most of these people spend between 10 and $20 or rupees or 1,000 rupees or so on and so forth, right? And I have that very few times it happens that people come in groups of sixes or fives, right? Singles also come very rarely, so just a single person coming to a restaurant and having a meal or dining there is also rare for this establishment. But twos and threes are fairly common. So that is the kind of insight that this kind of data is giving me. So again, it might mean that the kind of insights or the actionable information that I get from something like this is, if I'm planning a restaurant, right, I need very few tables that are big enough to host 5 or 6 people, but I would much rather spend money and the logistic power that I have to get tables which can accommodate 2 people comfortably or 3 people comfortably, because I see that those are my most frequent customers or groups that come into this establishment. Okay, so these are the different ways that in which you can visualize, you know different ways in which you can think of which kind of variables should be visualized and how, and the kind of different insights that you can make. Okay, so again, this is a bit more stylistic and I'm trying to see how this changes from males to females. So for example, a cool insight that I can maybe make here is that females are much more okay coming alone than males might be, right? And again, this is just a theory that I might make looking at the data. There is a point where you will model it and try to validate it or not validate it. You have to check whether given the data set or given the size, I can make that claim in any statistically significant way. But it does tell me that it is a potential theory to have, right? Okay, so even larger group, so larger than 4 people, I can see that there are more males who come out in such large groups than females. Okay, so this is how cat plot works, and you can try to check how things are. So for example, here I have smoker, and if I just wanted to make 2 categories of smoker, and I can in fact even tell it the order in which it should do it. So non-smokers and then smokers and how much they tip. And looking at this, I might say that okay, maybe it doesn't have a huge effect, maybe just a small effect in how much they tip, right? And again, you can just always use group by to check how much difference is there. And this graph told me probably not that much difference in how much a person tips based on whether they smoke or not. And when I look at group by, I also see that you know there isn't that much of a difference, right? The yes average is 3.008 and the no average is 2.99. So really there isn't that much of a difference. So in case I was thinking that non-smokers tip more or smokers tip more, this data visualization tells me that probably that is not the case, that smoking drives how much a person will tip. So that is probably not a very important feature in predicting whether this person will tip high or low. Okay, so cat plots, again, this is something where I can use a cat plot for different days, and I can see if people are coming in more for lunchtime or more for dinner time. And you can see that on Saturdays and Sundays they have almost exclusively come only for dinner, right? Again, as an establishment, one of the actionable things that I can take from this is, if needed, I could actually effectively shut down my restaurant on Saturday morning, and maybe that helps me better prepare for the dinner rush or dinner time where a lot more people will come. Whereas something like that would not be feasible on Thursday, because on Thursday people are overwhelmingly coming to this establishment for lunch, right? So another insight that I'm making using this kind of visualization. And of course you can just always try to check these things using a group by. Okay, so that's the swarm plot of the exact same information. And now we come to something called box plots. And the reason that these plots are really really useful, immensely useful in fact, is that these plots help me look for outliers in my data. So what are outliers? Outliers are anything which stray far away from my normal trend, or from the normal trend that the data is showing me. Okay, and very often if you have a lot of outliers, you will know that mean is not a great way to check how the population trends are, because outliers will affect mean a lot. And so at least it tells you, maybe you need to look at some other metric instead of mean to check what your total population is behaving as. So how do we check whether our data has any outliers or not? And that can be done using box plots. So let's just have a look at one of the box plots, and here I have them based on the days. Okay, so X is my day and Y is my total bill. And to check or to find outliers, what you do is you look at the data points which are not contained in your box. So this is a box plot, and these lines that are jutting out are called the whiskers. And essentially it tells you the different quantiles of your data, and all of the points which are not contained even in the whiskers of your box plot, or these lines here, these are all your outliers. So these are the data points which are showing to some level extreme behavior. Okay, and for some kinds of analysis we often just ignore them. Sometimes we do take them into account, but again we have to be careful. So if I'm taking into account outliers, then I want to be careful and maybe not rely very highly on the mean, for example. Okay, so and again you can do this for all kinds of things. So instead of total bill, I could look at tips, right? So the most outlier behavior for tips was on Saturday, where they went up all the way to 10. And what this is essentially telling you is that even if you were working on a Saturday, you know chances that you get a total tip of 10 from one bill are fairly low. That was an extreme behavior, and the chances of something like that are happening are not very high, right? So this is also some kind of information that you can gain from box plot. So the main purpose of box plot, uh, well, not the main, but one of the really important purposes of box plot is for you to figure out if there are any outliers in your data, and if there are, then to uh, which way is your data skewed in terms of outliers and otherwise. Okay, so this is the kind of information that a box plot can provide. And then you can, of course, add hue to the box plot as well, so you can see where more outliers lie. And then there are um, also different kinds of box plots that you can make. Okay, so what I did here was just added another column called weekend, and now what this allows me to do is put Saturday and Sunday together into a weekend column if I wanted, right? So again, you can create more features for your data where it might seem appropriate. Okay, technically I think it's called feature engineering. Okay, and very often it becomes very important for you to create these features that make a lot of sense for your analysis, which were not given in the original data. For example, I could classify tips into three categories: low, medium, and high, and then try to see where the highs lie and where the mediums lie, instead of just looking at numbers, and that might be more fruitful in my analysis. So something like that is what I have done here, where I have created a weekend column, and now I can look at whether something happened on a weekend or not, versus if it was on a Saturday, Sunday, or a Thursday, Friday, right? So I can now use that also to check for all of the different things that I have been checking so far. All right. Then there is a box n plot, which is basically also just still a box plot, slightly fancier, you could say. And to understand this a bit more, I will ask you to actually really just go and look at CBON website, because I'm already sort of running out of time here. Right. So you can see all of these same things in a lot of different kinds of plots. So I just want to expose you to the different kinds that are there. So you have something called a violin plot. And again, it's basically doing the same thing. It's almost like a swan plot, right? Where it is telling you in which region does most of your data lie, how varied it is, and the stretched outness tells you whether there might be potential outlier behavior, right? So that is a violin plot, and you can make these in for all the different variables like we have already discussed, and they will look different depending on what variables and what hue you are looking at, right? Okay, so again, the reason here you got these two are because on Friday you have both lunches and dinners, right? You can see that very few people came in for uh, dinner on Friday, but mostly for lunch. And whereas Saturday, Sundays, you people just came in for dinners, and this shows you how much people spent and how many people spent in a particular region of bills, right? So again, a lot of people spent around between 10 and 20, I think in this case, dollars, right? So this is something that you can do. And again, in this case, what I have done is, instead of having two different plots for with hue, I have just said, okay, on one side make it one hue, on the other side make the other category, right? So that is something that you can do, and for that all I've done is used split is equal to true. and you can keep on changing and making stylistic choices for however you want your plots to be. And you can also layer plots on one another, so you can have two plots which sit on top of each other in Python. So here what I have done is I have a violin plot, and on top of that is a swan plot. So this just shows you how they behave, and sometimes it is useful to look at two plots on top of each other to also get insights about data, right? So this is also something that you can do. All right. Finally, you can have box plots or histograms. I'm sure most of you are familiar with histograms, that you've at least heard of them. So you can make these in Python. And again, you does the exact same thing. And in this case, it's a count plot, so to say, right? So it tells you how much they have spent, right? And again, all I've done is I've plotted sex on the x-axis and total bill on the y-axis, and I distribute or I check how it differentiates between smoker and non-smoker. So this is how you can make bar plots. You can change the colors, you can add hues wherever you want, and so on and so forth. Okay, so again, bar plots, count plots, all of these things extremely possible, and a lot of these are just stylistic choices. So here, palette is just which kind of colors I want, and if you want to look at what other colors are possible, please look at the Seaborn documentation that has all of these, right? Okay, so I think I'll stop here. I've already overshot my time. Point plots are also just plots which show you the relationship or the trend that these things have. So, for example, here what it means is how much tip was received, maximum and minimum on each day, and the midpoint is marked, and then the midpoints of all of these different categories connected. So it does show you some sort of trends that might be in your data. For example, here it shows me as I move from Thursday to Sunday, the average tip that I might receive tends to increase, right? So it can show you such trends over time or over categories, and can be very useful sometimes. All right, so with that, I think I will stop. This notebook I will share with Anjali, and she can share it with everybody else. And if there are any questions, I will take those now. And I hope that this was an engaging and useful session for everybody here.
Thank you so much, Jayati ma'am. For it really was a really insightful session. If any of the students have any questions, they can ask right now uh, to Jayati ma'am.
Okay, someone says, can you explain these terms, hue, style, and height? So, hue is just